Hello everyone, welcome again in the live session. So in this live session, we are going to learn about circuits, electricity, lights that all over around you. Like I can see the light at my home, Diwali lights. I can see lots of things around me, and of course, you can also see them. So if I talk about circuits, if I talk about electricity, if I talk about lights, then something come in my mind, and I think in everyone's mind, like how this works. And it's really, I can say that a procedure like everyone should understand this. So for this, I'm sharing my whiteboard with all of you. Here, I want to ask one question to all the students, those are watching live. Like I will make the shapes and you will make the guess, okay, circuit, if I talk about circuit, so which shape it's relatable with, okay? So if I make a shape here, this one, so yeah, this is rectangle. So can anybody tell me in the comment box that rectangle is related to circuits? Yes or no? Please reply in the comment box. No, rectangle is actually not related to the circuits. Now, if I talk about a triangle, let me create a triangle. So triangle is related to the circuits. Yes or no? Please make a guess. Is it related to the circuits? Of course not. Now I will take another shape. Circle. So circle is related to circuits? Yes or no? I'm making a circle. Circle and circuits. Yes, actually circle is related to circuits. But how? So let me explain you a process of a circuit. Okay, like if suppose I have a power source, like if I talk about a torch, okay, I have a torch, I'll press the button and I can see that there is a particular light, like it can lighten up, right? Or in my mobile phone, I can simply turn on the light also from my mobile phone, right? The switch, the bulbs, the tube light at our home, we can easily switch it on, switch it off, right? But how it works? Actually, for making them working, we must have one power source, okay? So power source can be a battery or anything that has power, that has some electricity. Okay, so circuits allow electricity to flow, but this electricity must be in a circular path. Like I told you, circuit is related to circle. It should be circular path and the path should completely closed. So suppose this is my battery and battery is my power source. Now here, if I take a bulb, here I will draw one bulb. So this is my bulb. Okay. Now, here is my bulb. And if I connect, I should have to make the connection, right? So I'm making a connection with the wire. So I connect one wire here and one wire here. As I can say that this is a closed circuit, right? Closed connection. So this bulb will glow like this. Okay, but if the connection is break, like if this connection breaks here, then the bulb will not light up. It will not light up. Okay, so I am sharing my screen. I will tell you how this actually works on Tinkercad. Tinkercad is actually an open source platform where you can easily do experiments, whatever you wish to do. So I'm sharing my screen with all of you. The first thing, you will search for Tinkercad. I give the link in the like in the chat box also. You will do login first. After that, after the login, you will come to the design part. Then you will click on this new section and you will go to the circuit. When you come to the circuit, it will open up with the space where you can actually design your circuits. Now here, let's understand this. Actually, this is a very good software to learn about electrical and electronic devices, how they works and everything. So the first thing that I have is my battery source. Like I told you, battery source. It is very important. Why and how? I will explain you. Suppose you have a tube, okay? And you fill this tube with the beads. So I have the beads like this, like this, like this, like this, like this, like this. Now what happened? These beads are not together and these beads are in inactive state. These are not active right now. If I connect a battery, a power source to this, I supply one power here and I will close this with the power source. What happened is now there is the electricity. I can say that there are more beads that will start pushing these beads that's we are having inside the wire. So suppose if I have the balls and if I make a force with the number of balls, like I make a force here, then definitely it will move, right? So this way the electricity flows. Electricity supply the electric current through the wires with the help of power source. Okay, this is actually the process and how it works. Now I am taking LED. LED and bulb, these two are the different things. If I talk about bulb, it has no negative and positive sides. You can join the wire with the battery for the bulb anyway. It will work. But in case of LED, there is a specific negative and positive charge. If you are connected your LED with wrong way, it will not work at all. Let's see how to find the correct symbols, like correct sign for the LED. When you move your cursor on this leg, it's showing me anode. Anode stands for positive. So the positive of LED will always connect to the positive of the battery. Okay. Now, if I move my cursor here to the cathode, cathode stands for negative. Now, the negative of the battery, we always connect with the negative of the LED. Okay. So if like no if, there will be no confusion. Positive will connect to the positive, negative will connect to the negative. What I will do is that I'll put my LED here and I will make the connection. So first I will click on this dot. I will move it like this. I click on this. I click on this. Like if I want to make turn with my wire, I can click and then move. And then I join it with the positive terminal. If I want to change the wire color, so the positive color, I always indicate with the red color. Like this is my rule. I follow this like positive. I always follow with the red color wire. So I'm taking this. I did the positive connection of the battery with the LED. Now I will do the negative connection. So first I will select the color For the negative, I always take black color. Okay. So I will just click on this, click on this, click on this, click on this, and I'm joining it with the negative. So what is happening here? The flow of current will always be from positive to negative. When I connect something to the battery, to the power source, the flow of current will always be positive to negative. So the current starts flowing, the electricity starts flowing from the positive end, and then it's coming out to the negative end and to the battery. So my circuit is closed. Now how to play and how to check? What I will do is I will click on start simulation. When I did this, my bulb works absolutely fine. As you can see, there is like as my full name, like I have my first name and last name. Exactly for your components, you have the first name and last name. Like this is your battery. So battery is the first name. So battery we indicate always as 1.5. Actually, this is the number, but voltage. We always represent it as volts. Okay. Now, this battery is of 1.5 volt, means this is a force. How much amount of force I can have on the component? So I can have only 1.5 volt force on my component. Okay. So this LED can take 1.5 volt only. But if you give this LED a more force, more power, then this can be burst, right? So the voltage must be, according to your components. Now, instead of this battery, I'm going to delete this battery. Instead of this battery, if I use 3 volt battery, this is my 3 volt battery. As I can see on the battery, 3 volt. I will rotate this battery with the help of this triangle over here. And now I'm connecting the anode part to the positive of my battery, and the color I am going to change red color. And the negative part I'm connecting with negative part of the battery. Now, if I do start simulation, do you see the symbol over here? When I move, it's saying current through LED is 61.9 mA milliampere, while recommended maximum is 20 milliampere. The usable lifetime of LED may be reduced. Actually, as I told you that my LED can take only 1.5 volt. Okay, if I will supply more than that to one LED, then it can burst. So my battery is of 3 volt, that's why it can burst. But see, in our houses we have different type of bulbs. What we can put there and how we can reduce, like how we can define that only this much force required, only this much amount of electricity required to supply there. Actually, we have one more component that we called resistor. As it indicates by its name, resistor means that can resist something, that can resist the flow, the overflow of electricity. Okay. So the resistor also has its value. Like here, it's 1 kilo ohm resistor. Mostly I will use 220 ohm resistor. So I will change the value as 220 ohm. And now I will put this resistor to my battery and let's see what will happen. I'll just delete this connection. I don't want this connection. And resistor has no polarity. Polarity means there will be no specific positive and negative sides with the resistor. Okay. So what I will do, I'll simply take this and I'll connect to the resistor, and I will connect this wire to the resistor here, and the color I will change it to red, and this resistor you will put to the positive side, because you know the current will pass from positive to negative. So first the current will pass from the resistor, then it will go to the LED, right? So that it will stop overflow of current through the LED. Now I will start simulating. So as you can see, now there is no symbol because I put resistor. Resistor will stopping the current, the overflow of the current, and it will pass only the limited amount of current to the LED. I think this concept is clear for most of you. You can write in the comment box if it is clear. Okay, now I'm going to delete this, and what I want is I want to put one switch here. I don't want that if there is electricity supply all the time, the bulb of my house, the switch of my the LEDs of my house will be turned on. No, I don't want that. So I want a particular type of switch. Actually, we have two type of buttons. Like I'm having push button. You will take out push button, and what you will do, I will just connect this push button to this terminal, terminal 2B, and terminal 1A I'm connecting with this. Okay, because the diagonal terminals are connected in push buttons. Okay, so what switch will do, I will explain you. Switch will help you to like for the circuit to open, to make it open and close. Like if you turn on the switch, then it will make the connection of the wires like this. This is the case of turn on. And if you turn off the switch, it will break the connection. So the connection is break. When the connection is break, then of course there will be no supply. So this is the push button, means if I push, then light will on, otherwise the light will be off. Okay, if I click on start simulation, and if I click on this, see, when I do this, then only the light is on, otherwise it's off. Even I can change the LED color. I will change the color to orange, and when I do this, this happens. Yeah, I will explain you one easiest thing for making the connection. Like this is the connection that is without board. We are having one board also where we can make our circuit connection. So I'll just delete all this, and that will make our connection so easy and convenient. Every component will be at their places and the connection will be very good. So I'm going to delete this battery now. What I will do is I will introduce you another component here is breadboard. So this is the component, that's breadboard. Let's understand the breadboard now. Breadboard is actually a board which is used for the components connection. Means if you wish to make the circuits, closed circuit, open circuit, you will have the breadboard for the connections. Okay. What I will do here is, what I'll see here is that there is negative sign given, there is positive sign given. If I move my cursor on the positive, I can see this complete line, and these lines are joining together with the green color circle line, circle line, circle line, if you will see over here, right? It means this complete line has a same flow of current. Okay, here it's written positive, so I can put positive wire here for the current flow. Now here, this complete line has same flow of current, that is negative. When I come inside the breadboard, here above, the horizontal lines has the same flow, but when we come inside, there is the vertical lines has same flow. Like this line has same flow of current. Okay, these lines have same flow of current, kind of. Like if I move my cursor here, you can see there is a vertical lines that is having the same flow of current. So the arrangement of breadboard is like that only. Okay, if I talk about the lines, so here the horizontal lines having the same flow of current, and inside the breadboard there is vertical lines have same flow of currents. Okay, now I will do the connection of my circuit. For this, I will take out the battery. So this is my battery component, and I will connect the positive of the battery to the positive and the negative of the battery to the negative. Okay, so this is the positive. I'm connecting it to the positive. Now I will take the black color wire. This is the negative. I'm connecting it to the negative. This wire should be of red color, so I will change it to red color. That's it. My battery is connected to my breadboard. It indicates that this line having a positive flow of current, this line having a negative flow of current. What I will do, I will connect my resistor to the positive line. So I connect my resistor to the positive line and here with this line. Now I want to connect this LED with the resistor. So in this line, there is a same flow of current. So I can connect my LED out of any hole present on the breadboard. So I connect the LED here. That's it. Now there is one hole that's for the negative one, or I can take from here, like from this to this, I will create the connection. And this will be the negative connection. Okay. So, and from this line to this line, I am connected the negative connection, negative leg connection with the negative of the battery. Now, if I run this, I can see there's overflow. Why? Because there is only one LED I have. I will tell you one very interesting thing here. If I take more LEDs, see, I take LED, I will connect anode to cathode. The LEDs I'm connecting positive and negative, okay, like this way. And then I'm taking another LED. I am connecting this LED here, okay. And this LED I will take with different color, suppose green color. I will take another LED and I will make these two LED connection, and then I will make the connection, the negative connection to the battery, the negative of the battery. Now, if I click on start simulation, you can see that every LED is there, but there is no symbol coming like the bursting symbol. Why? Because this type of combination we also called as series combination. In series combination, what happens? The voltage divides to the LEDs. Okay, so I took one LED, it's having 1.5 volt, like it can take 1.5. Then second LED can take 1.5, 1.5, 1.5 is 3 volt. Then I'm taking another LED, 3 plus 1.5 and 1.5 is 6 volts. It can take 6 volts, right? And I have the resistor also. That's why it's not showing me the danger sign, because I divide my LEDs with the voltage, right? And this type of combination we call as a series combination. What if I delete, like I just remove this one circuit, like this one connection? Okay, and if I click on start simulation, nothing happens. Means in series combination, the number of LEDs are present. If one LED is getting off, it means the complete circuit is getting off. This happens in series combination. And this is the example of Diwali lights. It happens with our Diwali lights, like at our home, we have lots of lights. And if one bulb is getting off, then the complete light is off, right? But at our homes, this kind of thing doesn't happen. How to know more? We have our course that's based on basic electricals and electronic devices. We will do experiment on the breadboards. We have these things in actual. You can practice on Tinkercad as well. You can make it in actual with the actual real components. So if you wish to know about these things, then please enroll our courses. And we have every kind of course for every age of students. Okay, if you want to learn advanced version in electrical and electronics, you can definitely learn that. You can enroll our courses. And yeah, so this is all about our live session for today, and we will meet in the next live session now. Bye bye, everyone.